All right, question one. We'll read through this. It's a lot of reading on all of them. But what happens is we have a circle. The center is at the origin, that's 0, 0. And then we have a ray that goes out and creates an angle theta. And then we're going to drop that line down and make a right triangle with angle W. So for this particular example, W and theta are the same angle. We can see that from our picture. They're not always going to be like that. So given a vertex opposite a leg on the x-axis and its hypotenuse is a radius, what is the value of sine theta? So what happens is we created a right triangle inside of a circle here. So this length is the radius of the circle, but it's also the hypotenuse of our right triangle because it's across from the right angle. So that's our hypotenuse. And then we want to find sine. So I'm going to label our other sides. So across from theta, this is the opposite side. And then the one next to it is called the adjacent. And we actually know some side lengths here because of this point. So think about when you graph a point, you go over 12, up 16. So we're actually given the sides. This side's 12 and this is 16. And to find sine, sine is opposite over hypotenuse. So we already have one of these. We have the opposite at 16. We need to solve for the hypotenuse using the Pythagorean theorem because we have a right triangle. So remember that side's always C, and then the other two sides don't matter. A and B can be either order. I'll do this. So Pythagorean theorem is a squared plus b squared equals c squared. So a is 12, b is 16, and we're going to take the square root of that to get c. So I'm going to type it in just like that. Square root of 12 squared plus 16 squared is 20. So c is 20. That's our hypotenuse. So 16 over 20, and that reduces, these both divide by 4. So sine is 4/5. Now it's saying what is the measure of angle W in degrees, rounded to one decimal place, and then what's the measure of angle theta? And because our triangle's in the first quadrant, they're the same, which is nice. So to solve for an angle, we take our value that we already found. We found sine of theta equals 4/5. Well, we want to get theta by itself. That's the angle. So in order to get rid of sine, we take sine inverse of both sides. So sine and sine inverse are opposites. We're just left with theta. So sine inverse of 4/5 will give us theta. So come over here in graphing. You always need to make sure you're in degrees, not radians. And then under functions, our trig functions are all at the top. So inverse trig, inverse sine is 4/5, 53.1, rounded to 2 decimal places, degrees. And that goes on both of them because they are the same angle in the first quadrant.